Hey there. Welcome to CyberPulse by Quantum Shield, the podcast where we make cybersecurity less intimidating and a lot more exciting. Every episode, we're diving into the latest digital drama, from sneaky hackers to the coolest defense strategies, all while sharing tips you can actually use. So grab a coffee, get comfy, and let's navigate this crazy digital world together.
Ever wonder what keeps those online services you use every day safe from digital attacks? Today, we're doing a deep dive into the world of secure coding. Think of it as learning the secret language of building software that's truly fortified.
Precisely. It's about weaving security into the very DNA of any system, and today we'll be focusing on the essential principles that make that happen.
Okay, let's unpack this.
Yeah.
So where do we even begin with securing an application?
It all starts with recognizing that any data your application handles is a potential entry point for malicious actors.
So like a fortress with multiple gates that all need guarding.
Exactly. And one of those critical gates is user input. That's where input validation and sanitization come into play. It's about ensuring that any data coming into our system, whether it's from a form submission, an API call, or anywhere else, is carefully checked and cleansed.
Like having a strict bouncer at the door, verifying everyone's ID before they even step inside.
Absolutely. Techniques like whitelists, where you define exactly what's allowed, regular expressions to filter out potentially harmful patterns, and even something as simple as enforcing length restrictions are all part of making your application a fortress, not a playground for hackers.
Makes sense. So we've got our defenses up at the entry points, but what about the information flowing OUT of our application? We need to make sure that's secure too, right?
Absolutely. Let's talk about output encoding. You see, web browsers interpret the code they receive, and if an attacker can inject a malicious scripts into the data your application sends out, that could lead to something called cross-site scripting, or XSS.
XSS, that sounds serious. What kind of damage could those vulnerabilities actually cause?
It can range from hijacking user sessions to stealing sensitive data, even redirecting users to malicious websites without them even realizing it. Imagine an attacker getting hold of your banking credentials just because you clicked on a seemingly harmless link. That's the kind of danger we're talking about.
Whoa, that's a stark reminder of why this matters. So output encoding acts as a translator, ensuring that any data displayed to the user is interpreted correctly by their browser no matter what.
Exactly. It neutralizes malicious code, preventing it from being executed by the browser. It's a fundamental layer of protection against XSS attacks.
Okay, so far we've covered fortifying our entrances and exits, but let's face it, no system is perfect. Errors happen. How does secure coding handle those unexpected bumps in the road?
That's where error handling and logging come into play. First, it's crucial to handle errors gracefully without revealing too much information that an attacker could exploit. Think of it as a magician's trick. You want to amaze your audience without giving away the secret.
I've always wondered about that. How exactly does a developer strike that balance between providing helpful error messages and not giving away too much information?
It's about being deliberate about what information is displayed to the user and what's kept behind the scenes. Generic error messages are your friend, while detailed stack traces should be logged securely for internal analysis.
So it's like leaving clues for yourself, but not for the criminals, right? And that's where logging comes in.
Precisely. Centralized logging creates a breadcrumb trail of events within your application. Imagine it as a security camera recording everything that happens. This allows you to investigate suspicious activity, retrace the steps of an attack, and even identify vulnerabilities that need fixing.
It's like having a detective's case file documenting all the evidence, essential for solving those digital mysteries.
And speaking of keeping things under wraps, we need to talk about handling sensitive information, like passwords and API keys. Never, ever hard-code these directly into your application.
So no more sticky notes with passwords on monitors, got it. But seriously, what's the big deal with hard coding?
It's like leaving your house key under the welcome mat. If an attacker gains access to your code, they have everything they need. Store this information securely, either in configuration files or, even better, in dedicated encrypted storage. Think of it like a high-security vault for your most valuable digital assets.
Makes sense. So we've talked about guarding entrances, securing exits, handling errors gracefully, and locking away sensitive information. Anything else we need to keep in mind?
Staying up to date with software updates and security patches is absolutely crucial. Outdated software is like a house with cracks in the foundation. It's just a matter of time before someone exploits those weaknesses.
It's like regularly upgrading your security system. You've got to stay one step ahead. Speaking of which, let's talk about a big one, encryption. It sounds incredibly complex, but I'm guessing it's pretty important.
It's the bedrock of modern cybersecurity. Encryption is like putting your message in a locked box that only the intended recipient, with the right key, can open.
Okay, that makes sense. But are all encryption methods created equal, or are some stronger than others?
Excellent question. You want to be using robust encryption algorithms like AES 256 or RSA. They employ complex mathematical functions to scramble data, making it virtually impossible to decrypt without the proper key. And of course, how you manage those keys is equally important. Think secure storage, rotation, and access control.
So it's not just about locking the box, it's also about who holds the key and how well they protect it.
Exactly. Now let's talk about another critical aspect, secure authentication and session management. It's all about protecting user accounts from unauthorized access.
So no more sharing passwords or writing them down, right?
Right. And it goes beyond just creating strong passwords. We're talking about storing those passwords securely using techniques like hashing and salting, which transforms them into unreadable gibberish, making them useless even if stolen. Then there's multi-factor authentication, which adds an extra layer of security, like needing a one-time code from your phone on top of your password.
It's like needing both a key and a secret code to open a vault.
Exactly. And we shouldn't forget about securing the user session. Think session timeouts to prevent unauthorized access if a user walks away from their computer, and defenses against session hijacking attempts, where an attacker tries to steal a user's session ID to impersonate them.
Wow, we've covered so much ground today. From validating inputs and encoding outputs to handling errors gracefully, encrypting data, and ensuring robust authentication, it's clear that secure coding is multi-layered and essential.
It's a continuous process of understanding vulnerabilities and applying best practices to mitigate them.
So for all the aspiring developers out there, what's the one thing you want them to take away from this deep dive?
Never stop learning. Security is an ever-evolving field. Stay curious, explore resources, and never assume you've got it all figured out. There's always more to learn, and that's what makes this field so fascinating.
Thanks for hanging out with us on CyberPulse. Remember, cybersecurity doesn't have to be scary. It's all about staying sharp and a little bit savvy. Keep learning, stay curious, and don't let those cyber gremlins get you down. Catch you next time, and until then, stay safe, stay smart, and keep crushing it online.